Hello and welcome to another video. This time we're going to be dealing with the very, fiddly topic of basically planning a nice new CRISPR manipulation. So, without further ado, let's just jump right on in. So, once again, we'll be using OGT as a test example because, hey, you work with what you know. And so, in this case, it's the mouse OGT that we're going to be looking to modify. So, here we are at the CRISPR search page, which is linked in my bio, and if, in our case, we select mouse, and then we select OGT, and it offers us lots of options, and for this worked example, we're going to be using exon 3, which I picked basically at random because we've never worked on it. It's all hypothetical. The point is the approach. So, let's take a brief pan over to our friend CLC Workbench, and here we have exon 3 all set up and good to go. So let's minimize that, and the framing is correct. So the amino acids for the highlighted section, which is in a burgundy, is exon 3 in all its glory. And let's say for our example we want to turn this CAG, glutamic acid, I think it's Q, into a his, so CAG to CAC. So let's just add an annotation there for his. Okay, so that is our goal, that is our target. So now that you've established here is where you'd like to be, let's see how Mother Nature feels about that little idea of yours. Because after all, she has her own plans sometimes. So what we want is guide RNAs that are basically close to, or in a perfect universe, right on top of. And because it's a higher organism, such as mouse or humans, you use the nickase is the more sensible option, simply because it requires you to make two guide RNAs, and you're coupling a left-hand guide RNA that nicks one strand and a right-hand guide RNA that nicks the other strand, and only when these nicks occur in incredibly close proximity does the DNA actually break, set off the alarms, and make recombination very much favored in terms of repair. And that's what drives CRISPR-Cas9 modifications. So, now that we've got this in mind, let's see what we can see. So, switching to our web browser and asking for CRISPR pairs in table, we hit this and we now pan down. And there is a lot to unpack from the get-go. So there's several things that you should be looking at in this diagram here. So, here we see spacer, which has nothing to do with outer space. It's all about how close are the nick sites. In a perfect universe, you'd like them between 0 and 10 bases apart. That's your perfect. But basically, needs must as the devil drives, any port in a storm and all that. If it isn't 0 to 10, it's okay. Sometimes, yes, you'll have to pick, you may have to choose between the devil and the deep blue sea. But now, okay, you've got that detail. Let's pan over to other significant details. You have the genomic location, which, yes, is indecipherable to me, but we are going to cheat, because why not? Point is, and also, you see that the first two guide RNAs on the left-hand side are actually the same guy repeated. So it's a question of the left hand is the same, the right hand is different. But now, using our Woodstock pointer, let's focus at this off-targets thing, because this is very important. If you haven't heard of them before, you should be afraid of them. Off-targets are like the boogeyman of CRISPR. So, first we have how many things with 0 mismatches? And the answer is 1, because this exists in the genome. Duh. If this 1 is anything less than 1, anything more than 1, if it is 2, it suggests, good grief, you've got a freaky repeat. And that's a whole separate set of problems, which we'll discuss at another time. However, single mismatch, number 1 there, 0, love. 2 mismatches, 0, love extra. These are your two ideals. 2 zeros here, that's your, to me, that's your baseline ideal. If you have that, this is a good guide RNA. Sure, it would be nicer if the 3 mismatches were really low, which they are. 6 is a tiny number. This already is a very persuasive guide RNA. And the last one is just decoration by this point. 110 4 base mismatches, is my reaction to that. So, and look, just panning over to the right-hand one in this particular pair, because yes, the spacer is kind of large, but on the other hand, the off-targets for this right-hand one are similarly delicious. You see 1, 0, 0, 4, and 44. I mean, if it wasn't for the spacer, those guys are already very, very much getting my attention. But, and similarly, panning down here, we see this, 1, 0, 0, 4, 44. It resurfaces here again, but with a more desirable spacer, 5. And this one also pretty desirable. So it is a kind of like a dance thing, and everyone's switching partners. So let's actually see where any one of these guys land. But also, I mean, just to also reassure you, or maybe not reassure you, not all is good and shiny. For example, this gRNA over here, I mean, 1 in both of those things? Ooh, I mean, I would have to be jolly desperate or crazy to go with that one. I mean, that one makes me more than a little nervous. It may still come out okay, so it's not unacceptable, but I'd rather not. It's like picking a used car salesman at this point. And similarly, panning down, you've got other brothers that may even be the same one. Yes, resurfacing again. So, now that we've done some gratuitous browsing, let's actually get serious and see, okay, where exactly in the exon do these occur? Because they are organized chronologically or sequentially. Let's go with sequentially. So these guys should be up front and therefore potentially be desirable. So let's grab this chappy here, which is the 10010-141. That's a lot of numbers, but anyway, let's ask CLC, where does this guy bind? Find and check. Oh my goodness, that is very well placed, as you can see. The stranding, it doesn't realize that this is on the reverse strand, but the PAM site is here because it's NGG, but it's on the opposite side, so that's CCT. So the actual 20 nucleotide starts at that letter L and goes all the way to the end of there. So hey, your alteration is inside the gRNA. Beautiful. You're going to be messing with that anyway. So that already has my attention. I did manage to forget this one's reference, so let's just hop back real quick. I always tend to note down only, well, the numbers that aren't 0 at the end. So this I would call 10-141. You with me? So pan over here. I mean, we've already, I think, found Elvis, but okay. Add annotation and call it 10-141. But because it is the left-hand side, we'll tell it this is on the minus strand, don't you know? And boop, we get an arrow facing that way for the left-hand guide RNA. Now we pan over here and go to its delightful dance partner with a 5 spacer and copy, though we kind of already know how this is going to go, because they are only 5 nucleotides apart, the cut sites, so find and V. Yeah, oh see, the tail ends are only 5 nucleotides apart. So that is really very good. So add annotation. And I managed to forget that one's reference. So once again, it's easier when I have multiple screens. So 444. Okay. So name you. Oh, come on. 4 space 44. Zap. I mean, basically, let's take one last look, but I think we've basically already found our winner. But just for completeness, to be unbiased, the last thing that you really, really need to do, and you'd think, okay, I've already found the off-targets, but the important part is you check this button, which hasn't been pressed yet. You hit that, and it runs a check of where are all the off-targets next to each other, because this guy does have 151 off-targets, and that one has 48. But are any of those coincidentally near each other, which could spell doom? The answer is no. The closest, none. The maximum distance is 1,000, which is basically safe. Because, just for giggles, hit that one's button as well. Similarly, passed as well. Passed. You almost never see a fail unless the guide RNAs are really, really stinky. That's the technical term. Yeah, boop, see, winning, winning. They just don't do this by default. But yeah, they're all good. But yeah, in short, unless 10 for 1 has an even better dance partner, I ain't seeing it. I mean, okay, that one, the overlap is 0, but I'm assuming this guy, even though it is very nice in terms of stats, it's probably still not going to dethrone Elvis. So, find. No, I would call that less good. So, this has actually been a rather quick worked example. And, yeah, really, please feel free to ask questions because, yeah, this isn't the be-all and end-all. In fact, this is just the warm-up. Because, after all, the next step you have to do, which is a more involved process, after all, this is an indication of intention. You've marked where you'd like to build the thing, but now what you have to do is introduce not only your histidine change, CAG to CAC, or CAT, dealer's choice. The point is, you still have to introduce, well, either you have to disable the PAM sites plus on both sides, so the CC here and the GG there, plus 2 changes. Well, okay, you get those for free with the one of the his. Point is, either 4 changes in the regular guide RNA or 2 changes plus a PAM killer. That's your minimum change you have to design. I'm not going to go over that yet. This is just a teaser, if you will, of the next stage, because there's more videos to come. If you want to know more, if you want to say what you'd like me to cover in the next video, please don't be shy. I look forward to your comments. I will read them. And if you also want to know more, check out the links in my bio, and don't forget to like and subscribe. And thank you.